Hello and welcome to this DCD Talks. We're going to be talking about AI data center building block solutions. My name is Kat Sullivan. I'm head of channels compute at DCD, and I'm very excited to welcome Johnson Eung, senior growth product manager in AI supercomputing at Supermicro. Hello, Johnson. How are you today?
Hey, Kat, it is my pleasure to be here. Thank you.
It's our pleasure to have you. And look, for those in the audience who may not know who you are, can you tell us a bit more about yourself? Introduce yourself. What is your background in computing and AI? What brought you to this role at Supermicro?
Yeah, thanks for asking. So I've been in the computing world for the last 13 years, and it's all been different areas of data center. So cloud, high performance computing, and AI before it was actually called AI. And it's quite remarkable to see the world now. I guess around 2023, I'd say was the inflection point where the world really took notice on AI. And suddenly what I did became interesting. So I'm glad that folks are interested to hear about what we do. And the reason why I'm at Supermicro is because I bring this holistic look on AI. So it's more than just releasing new and exciting shiny hardware. It's about looking at the entire AI stack, not just on the compute side, but also on like how it network and connects together and how it consumes power, but how we can also build in it with a green foundation so we can make sure that our planet is sustainable with as we grow with technology as well. So
Fantastic.
yeah.
That's always a great motive to have. But can you tell us a bit more about what's happening at Supermicro at the moment? How has the company evolved into being this major player in AI data centers? And what is the current focus for you guys at the moment?
That is a fantastic question. So, with companies, I've seen especially in the Bay Area, there's rapidly growing companies, and Supermicro, we've just hit our currently right now we're about 30 years old, more than that, but at 30 years old, we still have the same headquarters where I'm sitting right now from day one, and we still have our same fearless leader, Charles Liang, and it's also the same mentality. So we were created in 1993, but in 1999 we coined a term called building block solutions, or just building blocks. And the idea, if you haven't heard of building blocks, is just the ability to make things backwards and sideways compatible, right? We want to make every step of the solution more modular. So as we created our first motherboards, which is how we started, we wanted to make it so that it worked with as many platforms as possible. We're already thinking about reducing your need for buying things that are proprietary, having things more compatible so that as your environment changes, you can fit it. And so as we grow from motherboard to server, server to rack, rack to clusters, cluster, today it's AI data centers, right?
Mm.
Every single time we make these evolutionary steps, it's not just to try to capture a market. It really is that we create a foundation such that when we create a new product, the product is backwards compatible with every building block we had before it, and that becomes a building block itself for the next generation. And this generation of AI, what we're looking at is instead of, counting the number of GPUs, you need these scalable compute units that are perfectly balanced with power, with cooling, with networking, with all the cores that gives you the token counts that you need. And you need to be able to do that in a way that scales up quickly or scales down quickly. So that's essentially where we are today, is we're building AI factories.
You so rarely hear a company is preserving the mentality sort of over 30 years, that the concept doesn't change. But it's interesting to see how the concept has been adapted over the last 30 years. So can you talk us through specifically for AI data centers, what does the building blocks concept mean in practice? How do you bridge the gap, I guess, the link between the compute, the power, the cooling, the networking?
Yeah. Just for an oversimplicity sake, I'd say that if you're looking at any AI data center, and I don't use the word any very often or every, but we do find a constant hiccup in one of three areas, if not all three. It's either they run out of power,
Mm-hmm.
or the networking is not working, or they don't have the right design. So I would translate that to engineering expertise, right? And the last part isn't a lack of trying. It's that
Mm-hmm.
when you look at the data centers today, they don't they're deceptively similar to all the data centers you've seen before. But I promise you, AI is in its own field right now. Okay, if you're looking at, let's just look at power alone. Okay, right now, if you took a look at most data centers in the world, okay, just any data center, and you're looking at what's the average power draw in a single rack, it would be about 8 kilowatts, maybe 13. To translate that down, that's about the like three EVs, right, being charged simultaneously, or one American household with all the solar panels aggregated. So it's about 8 kilowatts. Now, if you're looking at AI's racks today that we have built so that it scales efficiently, we're up to 160 kilowatts. Now, to give you a sense, that is a Whole Foods size, like the Whole Foods market, that rooftop completely filled with solar panels can get you that much power. Or the Whole Foods parking lot, considering that it holds 45 cars, EVs, charging simultaneously. That's how much power you're using now. So in the sense, yeah, it looks like servers like the ones I have behind me. But if you're looking at what infrastructure is needed to be able to keep it cool, to keep it powered, it just doesn't exist. So for us, we had to help our customers create this from the ground up and give them very clear parameters of what they need to do this responsibly, safely, and green.
Mm. You mentioned the power considerations, you mentioned the cooling considerations as well. So let's talk about that in a bit more detail, particularly when it comes to direct liquid cooling. What role does this play in when we talk about scaling AI compute infrastructure?
Yeah, that's a wonderful question, and I could tell you that it's for those that aren't arms deep into the AI world, it's maybe seems like two different worlds, but really it's the same. So there's a move for GPUs and CPUs in that case, and these are GPUs are graphical processing units, CPUs are the compute processing units. You need both to have an AI server be working efficiently and complete. So the trend is they're always going up in terms of how much performance, like we think of it as performance cores, but also how many watts it's consuming.
Mm.
And if you're looking at just 2017 around there, a GPU might be consuming somewhere around 300 watts, right? Today, around 2025, we're expecting the GPUs to be over 1,000 watts. And in fact, CPUs now have exceeded what GPUs were in 2017. And we already have CPUs at 500 watts. Now, what that means is that now these wattages equal to heat output. And in order to control those heat outputs, we need to blow hot air through. And then there's air conditioning in a data center to try to offset that. Well, if you look at in the world of cooling, water or liquid is exceptionally more effective at removing heat than anything in air. Like to give
Mm.
you an example, to remove 1 liter of liquid from heat, it's equivalent to about 3,500 liters of air, right? So if you just take that kind of huge dichotomy, what we found that makes the data center actually green is instead of relying on fans to push the hot air out of the servers, we do something called direct to chip. Now, chip can be CPU or GPU, and we put these metal cold plates directly on, and the liquid doesn't touch it exactly. It just runs, and the cold plate is really good at extracting the heat exactly where the hottest sources are in the server. And so we have this running in a loop, and then we have our heat rejection device that happens elsewhere. You do that, and what that equals today is it takes 40% of the electricity that you would have otherwise wasted in just trying to blow cold air conditioning into your data center. So
Mm.
imagine every single data center who adopts directed chip liquid cooling up until now achieves 40% energy savings. Now that's just where we are today. And I promise you, even in by the end of 2025, that's going to look different because Supermicro, we really need to. We feel the we feel the burden of being the leader in showing what green computing means, especially as AI is being matured now. So we're continuing to push what we can do with liquid cooling and how we can reduce power consumption, how we can reduce water consumption, because we know that there's only one direction that AI is going, and it's just this explosive growth.
So before we run out of time today, we mentioned power, we've mentioned cooling. You've talked us through the building blocks. Just looking ahead for the future of AI data centers, what are some of the emerging technologies, approaches, critical challenges that you're seeing that needs to be addressed in order to manage current computational challenges?
Yeah, this is a fantastic question. So as you know, the number of tokens that is required to run and to have a more realistic video generation and believable AI conversations, as time goes, these tokens just explode, right? And what that means on the data center side is you need more GPUs. Now, to have more GPUs is one matter, but these GPUs, they don't work independently of one another. They work like neurons in a brain. So you need to have the ability to have all of these fire at the same time and be able to speak to each other without any latency. So this introduces a networking challenge that has never really hit this scale in any other computation or data center. So if you're looking at like a compute fabric, which is what we call the interconnect between GPU to GPU or server to server, you're looking at something where we use something called a fat tree topology. And this allows for a connection of not just a server to talk to another server, but every single individual GPU gets its own fiber optic connection. And not only that, but imagine like 1,000 GPUs, okay? In order for 1,000 GPUs to talk to each other, you don't just connect it to one another. You need to make sure that every GPU, if it was like, let's say, a quick moving vehicle, it has its own highway to every single other GPU in that 1,000 GPU stack, right? And there's no red lights. There's nothing to slow it down. There's nothing making them wait because this has to fire all at the same time. So in that sense, we create what's called a rail optimized topology. And let me tell you, the complexity is astounding. And 8 out of 10 times, when we find that a data center wasn't launched on time, an AI data center, 8 out of 10 times, it's the networking that has some kind of issues, right? So to give you a sense, for that same 1,000 GPUs, it's about 22,400 meters of fiber optic cables. Mm. Now, imagine trying to be the team that determines how you deploy that at a data center site. To cover 22,400 meters, if we were just running, just imagine Olympic relay runners. You would need 224 Olympic athletes to cover that distance. There's so many areas to go wrong, and just a little bit of dust that blocks it from the transceiver to the fiber optic cable is enough to completely halt the ability to communicate, right? Mm. And so there's lots of places for this to go wrong. And so for us, it makes sense to give you what's called a building block. So our building blocks will give you something like 256 pre-connected GPUs together, or 768. And those you can already rest assured and know these building blocks, you add those together, you say you need 1,000, take 256, multiply that by 4, right? And so for us, we give you these blocks so that you don't need to go through the headaches of making sure that it's designed right. so that if something is going wrong, you just know that it's an execution part that you need to troubleshoot. And most of the time, you don't even need to do that because we have our own on-site deployment team. We make that available to our customers. And so, we really are, when we say AI factories, we're taking it to the factory to build it.
Brilliant. Look, Johnson, we are out of time. I just want to thank you for joining me today. And I want to thank Supermicro for partnering with us throughout this talk. And also, we will be continuing conversations starting in June on the Compute, Storage and Networking channel and carrying out throughout the year. So I look forward to seeing how the innovations carry on, how the conversation develops, and what's next for AI computing. But for now, Johnson, thank you so much for joining me. And to our viewers, if you have any questions, please reach out to Johnson. I'm sure he'll be more than happy to answer them. But for now, thank you so much and goodbye.